You're going to stick around because for the landing, we're going to have you back out and we're going to enjoy it together.
Yes, I cannot wait. I'm so excited.
All right, fantastic. Thank you, Jessica.
And now we're about T-minus 7 minutes until liftoff of Sentinel-6 Michael Freilich on a SpaceX Falcon 9 rocket.
That's right. The moment is upon us. We're going to hand it over to Joshua Santora and Philip Hargrove for the countdown to launch. Guys, take it away.
Hey, thanks so much. It's been an active past few minutes, starting to hear calls of closeout and things. But before we go too far, I want to, Philip, ask you to introduce us to the teams that are on console today. So there are teams of teams really working this launch. Who do we have on board today?
You're absolutely right. So we have our international partners from the European Space Agency, or ESA, and the NASA Jet Propulsion Lab, or JPL, who have science instruments on board the spacecraft that was developed by ESA. SpaceX obviously manufactured and produced the Falcon 9 rocket, and the NASA Launch Services Program, or LSP team, has been working closely with them for the past couple of years to prepare for today. And the United States Space Force Range is responsible for public safety today.
Yes, grateful for everybody's participation. Lots of good comments made this week during briefings and reviews about just the incredible partnership and collaboration here. So I want to tell you about what's coming up through the rest of the count as we proceed towards liftoff here in just 5 minutes now. We should hear a call for RP1 full in just a second. And then we'll be looking for the strongback retract to take place in just a few seconds.
Propellant tanks are pressurizing for strongback retract.
Perfect. So what that's going to look like on your screen is up near the top of that rocket where the fairing is, just beneath the bottom edge of that fairing. You can see that on screen there very well. There's a clamp that's wrapped around the second stage of the Falcon. That clamp will expand, and then that tower, the strongback or transporter erector, will tilt back just a couple degrees in preparation for the final minutes of countdown. It will still be connected.
Retract has started.
There's that call. The retract has started. That strongback provides power, fluids, and communication for the rocket up until the time of liftoff, when it will tilt back even further away from the rocket. So keep your eyes on that. But Philip, wanted to have you tell us about the path for today's flight. The folks along the southern coast of California might get a treat if they're outside looking up to the sky.
Right. I'm definitely happy for the people out there in Southern California because, we get a million launches out here, but, if they can finally see some, especially at JPL, because it's, they're invested in this launch. So Vandenberg is really convenient for these high inclination launches. So Sentinel-6 Michael Freilich has a 66-degree inclination, which means that it's perfect for the Falcon 9 to launch south-southeast, and it's really going to kind of ride along the coast of Central and South America on its way up to that 1,300-kilometer altitude.
Yeah, very good. We just heard there Tim Dunn coming on the nets and giving his official go. So NASA is go for flight here. The last few minutes here, we're going to hear a number of calls with closing out liquid oxygen, or LOX, and then we'll kind of tick down here to the final minutes where we'll hear we're commanded for final pre-launch. We'll have the automated flight termination system will be configured for launch. We'll get a final go from the launch director at around 45 seconds to go on the way to 0 there, right on time for this instantaneous window at 12:17:08 Eastern Time. That's 9:17:08 there on the ground. So Philip, really fast here as we're waiting for the liftoff. Tell us about the rocket here. You kind of told us about the flight path, but what is this rocket capable of? There's a lot going on here.
Right, there's a lot going on, and we have some beautiful views of this Falcon 9. So you can see it's a two-stage rocket. The first stage, or the booster, goes about 2/3 of the way up, and that actually provides 1.7 million pounds of thrust, which is going to get the vehicle and the spacecraft off of the pad. The second stage, its engine is housed in that black interstage region that's just below the 5-meter fairing, and that's what's going to finally bring the spacecraft up into its orbit. And as we've discussed already, that first stage, once it separates from the second stage, is going to head on back to Vandenberg.
Awesome. So much coming up here. Post liftoff is certainly active as well. About a minute into flight, we'll hear calls for flight through max Q, or maximum aerodynamic pressure, and then we'll about 2.5. Strongback retract has been completed. There you go. You can see a nice separation there between the rocket and that transporter erector. About 2.5 minutes into flight, we're expecting to see a few things happen very rapidly. We're going to see that booster separate after that first stage engine cutoff happens, and then after that separation takes place, the second stage.
Stage 2 LOX load is complete.
There's that stage 2 liquid oxygen load complete, which is great. You kind of see some of the steam coming off the vehicle. That's dealing with cryogenic fluid that's on the order of negative 330 degrees Fahrenheit. That's densified liquid oxygen mixing with the ambient temperature there, which creates that fog, that steam effect. We'll also see a lot more happening post liftoff, so stay with us. And we even have a lot very, very late into the show today. We're roughly an hour and a half of milestones past liftoff of getting into the correct orbit and confirming that we have a good, healthy spacecraft. So please stay with us. There's a ton going on, but we'll let you listen in these last minute and just enjoy the countdown.
Falcon 9 is in startup.
Launch director is go for launch and landing.
You may notice some water beginning to flood the pad here. That's very intentional. That's actually a sound suppression system that occurs to allow the sound of the vibration of the sound to actually be suppressed, and it also helps with some cooling as well.
Falcon 9 is configured for flight.
T-minus 15. 10.
9. 8. 7. 6. 5. 4. 3, 2, 1, 0. And liftoff of Sentinel-6 Michael Freilich, continuing a legacy of ocean observation and international collaboration to benefit all humanity.
M1D propulsion is nominal.
Power and telemetry nominal.
Vehicle is supersonic. Vehicle is experiencing maximum aerodynamic pressure.
So there we heard that call for max Q. We also heard vehicle is supersonic, meaning it's traveling faster than the speed of sound. A beautiful shot there from the first stage looking down towards Earth and seeing the plume there created by those 9 Merlin 1D engines. Beautiful clear skies there from Vandenberg on the ground, able to track with that rocket as you see it on screen now. Just a reminder coming up here very quickly, we're going to hear booster or first stage engine cutoff.
Stage separation confirmed.
Booster separation is there visible on screen now. Beautiful shot. There's the backflip, as Jesse mentioned, beginning with the Falcon booster.
Stage 1 boost back burn has started.
And that second engine looks like it has lit. You can start to see the engine bell there turning an
Both
orange.
vehicles are following nominal trajectories.
Fairing separation confirmed.
And there goes the fairing. That's exposed. That is Sentinel-6 Michael Freilich there on your screen. That is the satellite that has been exposed now because the fairings have been jettisoned and separated, and you just saw it there tumbling away. Some beautiful shots on the way to orbit.
And stage 1, boost back burn, shutdown.
So we're getting reverse angle views of that engine on screen. That's what you're seeing. This is switching between opposite sides of that second
Both
stage.
vehicles continue to follow nominal trajectories.
And that term nominal being used, we've heard that a lot during this call out. That's a very good sign. Nominal just means that everything is going according to plan within the expectation of operation for the vehicle. So we are, there, a great shot from the first stage. You can see the hypersonic grid fins there that are expanded, those honeycomb-shaped structures. As the booster begins to enter the atmosphere, those will be able to help guide and stabilize the booster to make sure that we hit that pinpoint landing like we heard that question asked. How do we ensure pinpoint landing? And those grid fins play a huge part in that. That second stage is in the middle of its first burn. This burn will last approximately 6.5 minutes. And then there will be a long coast phase today. And then we will have a very short, a relatively short second stage, second burn to put us in the correct orbit to follow that path of the Jason series, as we heard earlier. So, Philip, from a trajectory perspective, is this just kind of a moment where do the people working this mission, do they kind of just sit and wait as well here? Because obviously we're not controlling this actively. It's just the vehicle, in theory, just doing what it's programmed to do.
Right. I mean, I will say I didn't personally work this mission, so I'm not sure what my coworker who worked it for the past couple of years is thinking, but it's beautiful to watch this trajectory that we've been planning out for years. We know what the math looks like, we know what the numbers are, but actually seeing these views from the second stage is just amazing.
Yeah, very good. And we'll talk more about kind of your role and what you do as a trajectory analyst. You are, by all accounts, a rocket scientist, which is pretty cool. We will come back and chat more in a bit. Again, we'll revisit you once we get towards that second stage, second burn. But for now, I think we're ready to head back out to check in with Daryl and Jesse to hopefully enjoy
nominal trajectories.
What I would expect to be a beautiful, very noisy nominal landing of that booster. Daryl, how was launch? How did it look out there? All right, we're going to hang off. They're not quite ready yet. I'm sure they're just enjoying it. They probably got up to watch that launch, and they're probably getting positioned again. So I don't blame them.
Me neither. Yeah, they should definitely soak it in.
So that second stage Merlin vacuum engine, MVAC as we like to call it, that produces around 210,000 pounds of thrust once it's on orbit in the vacuum of space.
Stage 1, entry burn has started.
All right, so call for the entry burn there. I think Daryl and Marina are ready for us. They should be there with Jesse to talk us through the landing. How was launch?
Oh my goodness!
It was incredible.
It was incredible.
That's why we're late. We're all
We're
all talking at the same time. It's great. Can you tell that we were excited? We were standing
Stage
there.
1,
We saw
entry
it.
burn
It was
shut
so
down.
clear we could see the separation as it was going the entire time. Jesse, I mean, isn't that
awe-inspiring?
Mind is blown.
so? It's going to be landing right behind us, and we've got a view now of the actual booster coming back. It's got its grid fins out. And that's helpful. It has to use those things.
Yep, it has to help steer it as it's making its way back to land. So it's the steering mechanism.
It's really interesting that it lands right next to the launch pad. We have a little tent over top of us, so we're not going to see that first boost back
Stage
burn.
1 is
But we
transonic.
have a clear shot of it coming down onto the pad. The other thing we're waiting for, and we're making sure that we keep track of,
Stage
is
1,
the
landing burn
engine
has started.
cutoff of stage 2. And we're going to call that out. Here it comes. There it is!
Wow. Oh my goodness!
Coming in at an angle and just straightening out. What do you think, Jesse? That's amazing.
Oh my goodness, I might cry right now.
This is so incredible. Every time I see this, it's just
Slowing down so perfectly.
perfect.
Just hovering.
Landing like that.
There's the sonic booms we talked about, and touchdown. Oh
we heard that.
Oh,
We heard
that was
yes.
And Falcon 9 has landed at LZ4. Landing operators proceed
Beautiful.
into 11.100 on recovery 2.
I'm a little
The
teary-eyed right now.
echo of the power to see it here in person, to feel it.
Oh, and like Jesse said, no matter if you see it or not, you always hear it, right? So that
Yes.
sonic boom is recognizable wherever
and
you are.
reverberating through the
Yeah.
valley
Oh, I
here.
know.
I thought that was-
Well, what'd you think, Jesse?
I have no words. That was incredible. Like, as many launches as I've seen, seeing it in person is a whole different experience.
The crowd that's with us, you can hear them
can hear
cheering
them
and everything. They're
cheering.
just totally
Everybody's
like,
so
you know,
excited.
in awe. We're so glad that we could do this and have you join us with this. Jesse Anderson from SpaceX,
Thank
lead manufacturing engineer. Thanks so much for coming out here. What a moment.
so much
Thank
for
you,
having me. This
Jesse.
has been amazing. Thank you.
Absolutely.
Thank you.
All right, well, the coast phase is about 45 minutes away, and so we don't expect any activity to report at this time. But if there is, we will let you know. And in the meantime, we'd like to tell you about the science behind the Sentinel-6 Michael Freilich mission. And we're going to get to that in a moment, but you know, we have a moment here where we're going to sync up and simulcast with our partners from the European Space Agency. And when we do that, that's going to allow both channels, both ESA and NASA, to carry the same broadcast at the same time. Going to talk a lot about science, and we're going to get to that in a moment. But first of all, I want to get your reaction to watching both the launch and the landing.
And it's spectacular, Daryl. I mean, it's so beautiful when everything comes, and like Jesse was saying, a well choreographed ballet. It's the best choreographed ballet in the world, and it did everything that it was supposed to. The launch was beautiful. I'm so glad the winds quieted down when they were supposed to, so that we could get that rocket launched, because this is incredible science that we're going to get from Sentinel-6, and I just can't wait.
Well said indeed. Okay, now we are going to turn it over to our friends from ESA. Let's join moderator Louise Houghton from the European Space Agency.
Sentinel-6 really would like to thank NASA and our friends in the US, also NOAA, for this contribution they have made. Incredible. They have been an excellent partner. They have been very reliable, and they really have delivered their part on time. And in very significant terms. The launcher we have just seen, but also very important instruments like the microradiometer and several other components. And this is a model cooperation I would really like with Thomas and his team in the US discuss further cooperation opportunities, because this is just so wonderful what we have done with Sentinel-6 Michael Freilich, and there is much more to come. I have quite a few ideas. I don't want to go into depth right here, but I think this is so successful that I would like to expand that.
Well, thank you so much, Josef. I think you're saying there that international partnerships are so important for these space missions moving forward. And we've, of course, been able to monitor the oceans from space for nearly 30 years now. And before we continue this conversation, I want to take a look at a video which will show our achievements to date.
Right.
Sorry, this is a little...
You're coming back to me, or?
Yeah, we are.
What would you like to ask me so I can gather my thoughts?
It's okay.
Nadia?
What difference is Sentinel-6 making to revolutionizing oceanography?
We've got time. We've got plenty of time. We'll be out after the video. You will have like six minutes.
I don't hear the video. I don't hear the video.
She's missing.
She doesn't have a feed.
Give me a cue.
Count you down.
altimeter was actually an experiment on board Skylab, which was 50 years ago now. I mean, the way that this technology has transformed over this last half a century is quite fantastic, isn't it, Thomas?
Oh, it's amazing. I mean, for me, when you just think about it, you know, you have this spacecraft up there at, you know, 1,300 kilometers, going at 8 kilometers per second, and you're locating it within a centimeter or so, exactly with all these, with the altimeter, but also the GPS receivers and the supporting instrumentation. For me, it's mind-boggling, you know, and of course, it's so important because it affects our lives in a direct fashion every day, even if we don't notice that.
What challenges do you think that we're going to come across in the future with working with this international partnership?
So look, I believe that for the first couple decades, the question really was, are the ocean levels rising? The question to that is absolutely yes. Now, the question that we're dealing with, and as an international community, is how are we handling these rising oceans, and how do we make sure we don't go to levels that we don't need to? And so for us, kind of the local impacts of those around the world, whether it's in Europe, whether it's in the United States, and everywhere else, are what's going to drive our research, and therefore the high resolution that this spacecraft provides us is absolutely critical. So that's the questions the international community has to come together to deal with these problems, because each one of those assets, you know, serves all of us.
Well, we have been hearing more and more about how oceanography has been revolutionized by satellite observation. So Nadia, maybe you can tell us a little bit more about why Sentinel-6 is making such a difference in that development.
Yes, Sentinel-6 is indeed building on a very rich heritage of JSON-class altimeters, and what we expect to see a new science coming out of Sentinel-6 that it would open up new frequencies that give us a fuller picture of what do we know about the oceans. And ocean altimetry by now, it's a mainstream tool of modern physical oceanography. So if you are a modern oceanographer, at one point of your life, you clearly looked with this data. Either you're studying tides or sea level, ocean circulation, or winds or hurricane prediction. You were exposed to this data, and we expect from Sentinel-6 to continue doing this discovery on a higher resolution and longer timescales.
Well, if Craig can hear us over in Europe, maybe I can come to you as well, Craig, and ask you your opinion on how this technology is really changing how we monitor the oceans.
To precision, which is essential because the annual changes are just a few millimeters a year. It's really remarkable. But, you know, it can do a lot more. And recent work shows that the oceans are taking up much more carbon dioxide from the atmosphere through the ocean-atmosphere interface, where waves play an extremely important role. Now, the Sentinel-6 Michael Freilich radar altimeter provides us with excellent measurements of the significant wave height with a 300-meter footprint size along the satellite track. Really, this will help us to improve our understanding of carbon dioxide transfer into the ocean. But it's even more than that. Wave forecasting is part of the Copernicus Marine Services for serving maritime operations, which are essential for maritime safety. And these are managed through the European Maritime Safety Agency. So we'll have topography measurements and wave measurements to really provide something pretty superb.
Well, thank you, Craig.
If you wish, it is up to you.
And that was Craig Donlan, who's the project scientist from ESA, which is the European Space Agency. So thank you so much to them. And the climate science conversation continues. If you would like to tune in, just use the Sentinel-6 hashtag on the European Space Agency or ESA's social media platforms.
This satellite was renamed after American oceanographer Michael Freilich, who led NASA's Earth Science Division for more than a decade. Freilich passed away in August, but 5 months prior, NASA held a satellite renaming ceremony for him at the agency's headquarters in Washington, D.C. Freilich accepted the honor, but he credited his success to the contributions of thousands of scientists, engineers, managers, and diplomats on both sides of the Atlantic.
It's been a privilege to work with you, to learn from you, and to be able to call you friends. The entire world is expecting great things from Sentinel-6, and I know that you will deliver. Go Sentinel-6.
Certainly he would have been thrilled to see this launch today. Joining us now is Daniel Freilich and Sarah Freilich, Michael's children, son and daughter. Thank you so much for being here.
Thank you.
So much for having us.
Very welcome. So, you know, you just saw this launch. Your father's name is on the satellite. What were your thoughts as you were watching that?
It was gorgeous. Like, I haven't seen something that beautiful before.
It's amazing.
It's my first time seeing a launch from out here, and to just see that was incredible. Like, it means so much to see and feel it. You know, like, I'd heard him talk about feeling it, and feeling that as it goes is just incredible.
Amazing.
And we all talk about him in the space community as just being such an inspiration. I had the honor of hearing him speak once as well. And you guys know the man outside of the work. So tell us a little bit about him.
So our dad was passionate, and like whatever he chose to do, he wanted to like be a big part of it, and like was in all of the communities. And I like to tell people I didn't have heartthrobs on my wall. I had ESA and satellite images as the posters. And so that was just who my dad was. He shared it with us, and you know, like he was always there.
And I think another thing is, you know, he cared about things at all levels. So not only did he care about an individual mission, but he cared about how it affected the entire world. And he did that with everyone he worked with. You know, he talked about the people that he worked with. He talked about all of the science that happened. When we were going through his papers, actually, we found that he still had the science papers written about the impact on the world. So he, even as he moved on, like, he just cared about every part of the process, the people, the science, and what it meant for humanity.
You guys were sharing a nice moment with me yesterday when you said that you know, you have talked to the people who worked with him. They talked about you guys, and then he talked to them about you. And so just sharing, you know, the mutual experiences, and said that he was just the real person, the real deal.
Yeah, and he would push everyone to be their best in order to make everything better.
And we don't want to forget about Rosie here. This would be his grandchild, right?
His first grandchild that he got to meet, so that was very special. Yeah.
Beautiful. She's rocking the Sentinel-6 shirt. Look at that.
You know, Sarah, you're a science teacher, right? So what part of this kind of carries through to what you do today?
So I think like we do a big unit on climate changing, because like for me, sea level rise and like what we can do as individuals is so important, and like what my father was saying. And so as much as I teach science, and I hope that each student can find something that excites them, whether or not it's like physics, biology, like rising sea levels. But I want to make sure that there's a space for everyone to find something that interests them.
And Michael Freilich had a red pen. Do you have a red pen?
Rosie has a red pen.
Rosie does.
Yeah, so Rosie got a
Carrying
red
on the tradition,
pen.
Rosie.
Yeah.
Just mark it up.
And it's so important, like you said, for future generations to be inspired and make a difference.
Yeah,
Thank you, guys.
That's what he wanted us to understand, that this was our planet and it needed to be better for everyone. And so he always said to us, it's not that there's climate change, but the climate is changing, to try to build unity around this topic and have everyone understand what impacts they can make and why it's important to all of us.
That's very well said. Daniel Freilich, Sarah Freilich, and Rosie.
Yes.
Rosie, we're so glad that you could be here for this moment.
Thank you
It's
so
just
much.
incredible, and thank you for sharing your father's legacy with us.
Thank you for having us.
Thank you so much for having us.
Michael Freilich believed strongly in the mission documenting sea level rise. Earth's oceans affect us all, from the air we breathe to how they impact our climate. Let's take a look at how Sentinel-6 Michael Freilich will help us continue to explore oceans from space.
Spend a few minutes on any beach and you'll realize just how much the ocean can transform the shoreline. We're here at NASA's Jet Propulsion Laboratory, and we're really excited about this new satellite. It will extend the record of sea level rise another decade past the 30 years we already have, and allow us to see how sea level is not only rising, but how it's accelerating. This has huge consequences for the planet, because sea level rise is one of the most important consequences of human-caused global warming. Sea levels are rising at a faster and faster rate every decade. We need these measurements to help us predict how quickly flooding will increase across the planet. Sentinel-6 will also bring us higher resolution measurements of sea level, which is incredibly important near the coastline where currents are narrow and changes can be difficult to observe from space. Currents in the ocean tilt the sea surface, making sea level high on one side and low on the other. Also, warm water stands taller than cold, so sea level measurements tell us about both ocean currents and ocean heat. Ocean currents affect our daily lives because the ocean has a strong impact on climate. In the west, the Pacific Ocean strongly determines droughts and rainfall, and in the east, hurricane forecasting uses satellite altimetry to help predict how much hurricanes will intensify. Ocean conditions can change quickly, and forecasters need data in near real time to predict how currents and marine weather will change across the globe. We're excited about the technical capabilities of this new satellite and the prospect of another 10 years of sea level measurements.
Give a little intro.
And Josh Willis is here, more affectionately known as Climate Elvis, joined by NASA's Blair Allen for a live demonstration.
That's right, Marina. Josh is here. The king is in the building with some
Thank you.
Deep,
Thank you very much.
deep insight into the science of Sentinel-6. So let's start there. Before we get to the demonstration, tell us a little bit about the science behind this mission.
Well, Blair, first I got to say, that was amazing.
I know, right?
I just saw that the rocket went up and then it came back down.
Yeah.
And so did the boom. It lowered the boom on us.
It did lower the boom, even when you know it's coming.
Yeah.
It's still shocking.
Boom.
Yeah.
Sonic boom. It was cool. But
it dropped the mic on us.
It dropped the mic, as I know you were going to do at the end of this segment.
Okay. Well, let's hear it.
So Sentinel-6 is going to tell us about the sea level. It measures the height of the ocean from about 800 miles up, and it does this with an accuracy of just 1 inch. And yeah. Right?
Yeah.
Pretty cool.
Yeah.
And so it does that everywhere in the world, once every 10 days. And from that, we can figure out global sea level rise, how much the oceans are rising because of human-caused climate change. So it's pretty neat.
Yeah, now one of our followers on Twitter, Ave, wants to know if they're twin satellites, why are they being launched 5 years apart?
Yeah, that's a great question. They're twins, but one's the younger twin. Okay. Significantly younger twin. So yes, so the idea is that we have to keep measuring sea level rise. Sea level rise is not going to stop anytime soon, and we have to keep our eye in the sky looking down on it. So we just launched the first one today. In 5 or 6 years, it'll start to age, and we'll launch the second one, and it will continue the record another full decade. Awesome. And that's a big deal because sea level rise is actually accelerating. So the rate of rise, in the 90s, it was about 2 millimeters per year. In the noughties, it was about 3 millimeters, the noughties, you know, the decade starting in 2000.
Oh, I know, but let's see the demonstration.
Yeah. Oh,
Go
okay,
ahead.
yeah,
Bring
sure.
us to it. Yeah.
Okay, so, all right. What happens when you hold a flame to a balloon?
I'm going to say it pops.
That's right.
But I'm just a layman.
Well, this layman is right. Let's find out, right? Now, in order to do this, I have to put on my safety gear. So here we go.
There you go.
Now, we're gonna do this, all right?
Yeah.
And it's gonna pop, right? Here we go. All right, 1, 2.
Wow.
It was terrifying, wasn't it?
Frightening.
Frightening, right? Now, what happens when you do the same thing with a balloon filled with water?
I'm assuming it pops as well, right?
Let's find out. Here we go. Look at that.
Fascinating.
Look at that. It's right there. It's right there on the balloon.
It holds.
It's not popping.
Why not?
It's not popping because water is so good at absorbing heat that it actually takes the heat away from the balloon before the flame can melt it. And that's just like the oceans. The oceans absorb more than 90% of the heat from climate change. So if we think about global warming, it's really ocean warming, right?
Wow.
That's pretty cool, huh?
That is amazing.
I'm really glad it didn't pop. You know, I was afraid I was going to have to give up all faith in science and join the circus or something.
We don't want you to do that.
No.
Well, thanks so much, Josh.
Yeah, you betcha.
It was... Yes. All right. So science has also left the building along with Josh.
Okay.
back to you guys at the gravel pit.
I'm going to go join the circus now. Yeah.
Okay. Well, Blair and Josh, thank you so much. I guess he's a hunk of burning balloon or something. Well, anyway, we want to recap the launch now. Just about a little more than 25 minutes ago. We launched from right here at the Vandenberg Air Force Base, courtesy of the 30th Space Force Wing. There it is, the Falcon 9 rocket and Michael Freilich spacecraft on at around 9:17 this morning, Pacific time, 12:17 Eastern time. There you see liftoff. The Falcon 9 rocket soaring into a beautiful blue sky over the central coast of California. The launch was picture perfect. Look at the shot right down the center of the rocket as it left the coast here. The mission to launch the Sentinel-6 Michael Freilich satellite into space. And as it got up off the ground, the launch, it seemed the rocket was taking its time, nice and slow. It's a nice heavy satellite up there. But once it cleared the tower and got up into the upper parts of the atmosphere, boy, it started to race. Michael Freilich's family were on hand to watch the launch, and it was just an incredible sight to behold. A wonderful a time had by all. We had guests and friends and relatives of Michael Freilich out here to watch it. And then just a few seconds later, about 8.5 minutes to be exact, the booster came back down to a nice soft landing. Just several hundred feet away, there came the booster touching back down on the landing pad. SpaceX now able to reuse that booster. And now the spacecraft is in flight and we are tracking its progress. Joshua Santora and Philip Hargrove are keeping an eye on the progress of the launch.
Oh, that was just...
It was something, wasn't it?
Inspirational.
It's incredible.
So beautiful. All right. Well, there are more than half dozen international partners on the Sentinel-6 mission.